Good morning, everyone. I'm Thomas Mangin from Exa Networks. I am very known to speak fast, so I will do an effort. If I do speak fast, wave your hand and I will know. I'm here to speak about something we've done, and here we come. Before I start to explain what we've done and what is this great new idea we have about fighting spam, I think a good, a quick recapitulation of what is a spam fight nowadays is probably in place. If you come back to the year 2000 or around that time, and you run your own mail server at the end of your DSL, you will have probably seen a lot of mail from your ISP at the time, trying to make sure you are not open relay. On those days, spam wasn't that bad. There was no we'll say bot at the time. There was mainly open relays, and RBLs were more or less taking care of it. People were already saying that mail was the worst service to run within an ISP, and that the good old days of the easy mail were past. At the time, more or less, all the mail was stopped by RBLs and by trying to figure out where the open relay was, which industry and collective effort would succeed to stop quite well. Nowadays, the challenge is to fight against botnets. Botnets are now large, very, very few millions of machines can be compromised. They can be used to send very, very high number of mails. You can see that the use botnet is not going to disappear. The bots are getting better, but currently we still have some advantages. Some of the bots are still not RFC compliant. You can figure that they are spamming spam at you at great speed and notice it, and the user grey listing. And with spam trap and other things, we can still get to the point where they can be stopped. But most of the defense now is done by the receiving mail server. Nothing is done at the source. All the fight have moved from trying to stop the machine sending to just defend the mail server and the MTAs. Tomorrow, what we can expect the spammers to continue what they do in their R&D, have better bots, more of them, more stealthy, able to do less connection, do more destination, and improve what they're doing, which means that it will become even harder to find what they're doing. And a lot of the techniques which are now appearing to be more popular are trying to do IP reputation, which means that if you are not a very large player with lots of IP address, lots of mail servers or user, you won't be able to build this database of knowledge to be able to assert, I would say, reputation of IP address. Oops. Yep. Where is it? Let's start. It was here. Yep. So what you can be sure of, that thing will not change. Tomorrow, what we know about mail, what you can probably guess, is that bots will continue to exist, that they will continue to use a lot of database of email address to try to find and guess email addresses, and that poor innocent machines of poor person will be used as a one-off throwing and to relay mail. So what was before is that with this kind of leverage spammer have using the network, spammer have a free distribution network. So what they do is they use innocent people machines to multiply and demultiply their mail sending, and until they have, as long as they have this free network or free delivery system, they will continue to send and probably meet their cost and be able to recover and continue to make spamming a lucrative business. So the idea is that if we can get rid of this network, then we are hurting them where it hurts in the pocket, and hopefully, like every business which costs have been driven up, we can expect them to go in slight recession. It will be fair enough. So I'm here to present what we wrote in open source software called Scavenger XA. It's not something which can help me myself to clean my mailbox. It's something which I hope others will deploy to keep my mailbox spam free, and try to get feedback from the community and try to get people to work with us to try to make that a success. So what is Scavenger XA? If you look in the dictionary, scavenger is an old word which more or less say it's an official charge with street maintenance. And that's what the software does, trying to keep the net free of spam. If you look where we came with that name, the joke is that it's more or less a carnivore eating junk. Carnivore being the FBI carnivore software. EXE Design is a collection of programs which work together to analyze the spam leaving a network and figure out abnormal pattern of sending. So the idea is that when you get in a network and you're an ISP or you're a hosting provider or a cloud, bots will not behave like other machines sending mail out. They will send mail once, they will send mail to a lot of destination. The way the machine behaves when it is used as a bot is not have distinctive patterns. So in order to get those patterns, we wrote a number of applications, which is a mail capture, conversation capture program, a dispatch server which allows to find what we found. I will explain on details later, which allow to take what has been captured and pass it through the network. A police server which allow to analyze the mail which have been copied. If you want, I will go in details, to detect those patterns, and some action servers which allow you to act on the discovery you just made. So if I go through the different elements, the first element is a software which will sit on your network and listen for mail conversation to extract those and allow you to treat them. The idea is that when you get mail is composed of command you send to the mail server and answer you get back. So what software does is that it will listen on your network, figure out what are the commands and what are the answers. From those, for each command and matching answer, for example, an hello and a 250 OK, a UDP packet is created. The UDP packet has this format. It's a key value form where the keys are as follows on the left and the value on the right, which explain more or less, I will go in detail from some of them, providing you views of what the conversation is about. For an example, this is a classical mail conversation with a greeting of the mail server, an hello from the client, the answer from the hello, and so on, until the point where the mail server decides that this user doesn't exist and terminate the conversation. That's the kind of things we are going to process. If we give an example, the first thing that we will see on the network is an hello and an answer. Those conversation network will generate one UDP packet, which will have this form. We can see that the origin is pickup, which means that the way we discovered these messages is using the pickup library. We can see that the status ST is hello, which means that we are at the hello stage of the mail conversation. The SI and DI give you the source and destination of the mail server, so the client and the client starting the conversation and the mail server accepting it. It has a unique ID, which is used to track the conversation uniquely. You can see at the bottom the hello string and the return code of the mail server, in that case 250. At the next stage, the mail from, we can see that we have more information at this point. The status has changed to mail, and the answer is still 250, but a different 250. And we now know the sender, which is SE, and the packet has been updated. At this point, so two messages have been sent, the first one for the hello, and the second for the mail from. And that's the last one. At this point, we have the last part of the conversation. We can see that that's the part where the mail server has refused the conversation with a 550. We know now that the conversation is for the recipient, RE, and we know that we have seen, up to that point, one recipient. If more recipients have been given, the RC counter will have been incremented, and only the last email address will be present on the message. So what do we do once we have created those UDP packets, which are representing the mail conversation? Once we have them, we pass them to the dispatch logic, to the dispatch server. The dispatch server takes those UDP packets and will then work with them through the rest of the application. It takes the UDP packet and will dispatch it to the policy server and to the part, which I would probably explain better through a diagram. That represents your work. So somewhere in your network, you have your capture software, which is listening on the wire for your mail conversation. That once it's listened and he found a part of a mail conversation, this conversation, for example, for the hello string or any of them, will be sent to the dispatch server using UDP. You can decide to round robin between multiple dispatch servers for load balancing. You can use different capture server to a number of dispatch server. You can decide to have multiple dispatch server per capture server if you want to get copy of the message for replay, or it's quite flexible. So, from your mail conversation, you create a packet, we go to dispatch server, we then will send the same exact packet via TCP to a policy server. The policy server will then look at what has been sent and keep a state of conversation per IP address or per network or whatever, and from the information you have seen, give an answer about what he thinks about the IP address. More or less establishing a reputation, keeping track about the usage of the IP address. So if an IP address, for example, is very known to only send mail to your smart host and only 10 mail a week, and suddenly start to send much more, it's something that can be found by the policy server, and as a result, this one will be able to issue a message saying, I do think that this activity is suspicious, and send a message back to the dispatch server. The dispatch server then is able, from the source IP address, to figure out what he should do with the answer and dispatch it to the correct action server. Let's say you have multiple DSL, one in London, one in, let's say, in France, for example. You may want to take action in different places. So you may want to share your infrastructure, like the dispatcher and the policy, which are TCP-based and can be hosted in a local common place, may want to take specific action or do different things depending which NOC you are going to speak with or which equipment is going to do something to stop the port 25 of the sender. So it allows you to send the action, and from that, someone could do something about it. The policy daemon we wrote is more or less, if people have been familiar with postfix policy daemon, an adaptation of our own policy daemon. So it will take the new format I just presented in his input, and as a return, we'll give you an action which can be, or say it's ARM, so more or less say you have no idea what the mail is about and we don't think it's suspicious. It can tell you that you should hold the mail, which means that the sender should be blocked. Or it can tell you that you should filter, which means that you should redirect the mail connection to somewhere else. For example, to your filtering MTA you have in your network or something else. You can specify on the policy server where you want the filter to happen. You can give the IP address, but you can as well let it blank. In that case, that can be decided at the edge of your network. We may know better about your network than your filtering. So if you, for example, are sharing your policy daemons, you may very well want to leave the IP address blank, and when the message arrives to the edge, replace it by something you know will correspond to that edge usage. As well, you can specify a duration for which you want to filter it, as you may not be sure that, for example, that is spam. It may be just a hint. You may just want to filter them or block them for like a few hours, which would be enough for you think the spam run to have stopped. I will not get into the detail of the daemon itself and the software itself, as it would be quite time intensive, and it probably don't relate to this audience, as you will need to want to look into it if you want to develop about it. If you're interested, you feel free. I would be very pleased to explain it to you. But the main idea is you can do multiple things with it. You can run multiple plugins in parallel. Each plugin can have two stages. A stage where you can store in the DB information. For example, if you want to keep track of information, you will always want to do those things. And the second stage, which is where you classify what you have. You give an answer, spam or no spam, which you may want to run only selectively, for example, only on hello message, or only on mail from, or only if your particular installation use MySQL, as your plugin use MySQL specific DB usage, whatever. It's very flexible. The API is quite simple, and writing plugin can be done quite easily. We support MySQL, Postgres, and SQLite. Out of the box, if you look at our software, MySQLite is probably the simplest to just get a feel for it and just test it. We will not recommend it for production use, but it allows you to probably download software, install it, and test it within minutes. So once you have decided and found a spammer, a message is sent to an action server, or one or multiple action servers, as we call them, which will do something about it. The first one is a mail, which just allow you to send an email to a person to be informed that you have a suspicion about an IP address. But we have another one, which is a NetFilter program, which allows you to affect a Linux box to change your routing if mail go through that box. For example, that would be a first example of possible deployment of the software. You have your DSL users. We go through a switch on which you have your capture software. So you pour mirror your traffic to just not affect your live network. So whatever happens to that software doesn't matter as the mail is not going through it. Then the capture software will pass information, and then from there someone will be informed. Another way we can be done, which is how we developed it, is to intercept part of your network traffic using source routing to force the traffic through the box and make a Linux server act as a router, on which you can run the software and you can generate traffic, which allow you as well, as mail traffic is routed in and out for that box, to perform filtering on the same box. Obviously, you could very well have two boxes doing that or multiple one. That's where we think that people with large traffic would like to do, which is first extract the mail to go through a different switch, so they can isolate the small part of your traffic, which is mail, and only port mirror the mail traffic to simply not have problem of capex and opex or capex on the equipment if they have 10 gigs connection or others, which would probably mean that port mirroring on 10 gigs is quite expensive, and finding servers with 10 gig interface as well, which probably means that it's the way we will think that large network will do. The software is free. It was licensed under the Affero GPL, which means that we will expect everyone deploying it to contribute to the change done. Obviously, I'm not a lawyer, so as far as I know, you can write your own daemon using the protocol to extend it, and for example, have something which is specific to your network without disclosing it. So you want to create an action server which reconfigure your switches or reconfigure your routers on the fly and may not want to share that information simply as you don't want to disclose how your network works, that should be possible. It's available now. People can download it. We have set up, I would say, like for every free softwares, an SVN, a public SVN. We have some software which allow you to see how the software is being changed and follows developments, and we have a mailing list as well. The software has been built with Python and some, well, say, known library of it. Twisted Matrix will give us a very good async event-driven network engine with the Python pickup library and the classical Python module. You can probably just apt-get or install on the machine very easily. I would like to thank Solskjaer Clayton, which that idea came from, following his Pamint talk and discussion I had with him at the time. We have a website which is now there, on which you can download software. We can as well find a quick install manual. So if you just want to download it, test it, have a look on how it looks. We have output of normal run of it, so you can have a feel of what it looks like from the terminal point of view. And as it's a wiki, we'll expect people which are looking at it to be able to contribute if they want. That would be it. Any questions? Yep, I have a question.
Okay. I'm Adrian from Andrews and Arnold. A couple of things strike me about this. It would seem to discourage people from supporting things like TSL and SSL in their email servers, because obviously as soon as you support that, the system falls down. It also seems to provide an excellent mechanism for exactly what central government snooping on people's traffic would provide the means for ISPs to feed all that data to some central repository very easily. So both of these seem to be rather negative points about the suggestion.
For the first one, for TLS, yes, we don't discourage it. People can use TLS. The reason software is offline, not inline, means that we will not interfere with TLS traffic. If anything, if customers are using TLS or encrypted traffic, the software will not interfere with it, which means that if two offices are sending mail privately, they can still use it with the technology. If there were any mail server in the middle, or if you do a transparent proxying of your mail traffic and your business customers, then you have a problem with security. That doesn't have the issue. So that's why perhaps it's a good step, as it allows to assume everyone is innocent until proven guilty. Regarding the snooping, yes, I can see the point. I can see why we can be afraid of snooping on ISP network. I perfectly share your view. It would be very trivial to modify the software to do something else, but if it's possible, it can be done technically, and people want to do it. It's not to technicians to say what should be done. In that case, it's something what we should lobby it, or we should explain to government why it's a bad idea. That software is specifically about stopping spam. And I do think that we have enough of it already to not try every method we have. That's a bit. So thank you for your time, and have a good day.